Welcome to Homework Lib.
Hi, so in this case, what we're going to find is essentially we're going to deduce the Henderson-Hasselbalch equation. So we want to know, using a nice table, what would be the pH of a solution containing NH3 with 0.16 molar and NH4Cl corresponding to 0.22 molar. And we're told that the basicity constant for NH3 corresponds to 1.76 times 10 to the minus 5. So the reaction that we're going to be looking at corresponding to the Kb is equal to NH3 plus water that is going to produce NH4 plus OH minus. Remember that the concentration of NH4 plus is equal to the concentration of NH4Cl because this is a salt and it dissociates completely. So we can go ahead and use our ice table. In this case, this would be in molarity directly because we know the molar concentrations of each of the species. Of NH3, we have 0.16. NH4Cl, we have 0.22. Water does not enter equilibrium, and initially of OH minus, let's say that we have 0. The amount of change, the amount that is going to react in order to produce NH4 plus, it's going to be X. So at equilibrium, we're going to find 0.16 minus X, 0.22 plus X, and X. Now, remember that the equilibrium constant in this case is 1.76 times 10 to the minus 5, right? So this means that the amount that is going to react is going to be quite small compared to the initial concentrations. So we can do the approximation. First of all, writing down the value for Kb, this is going to be equal to the concentration of OH minus times the concentration of NH4 plus divided by the concentration of NH3. We can replace the values with the concentrations that we found at equilibrium. This would be X, 0.22 plus X, and 0.16 minus X. We can approximate that 0.22 plus X and 0.16 minus X will be approximately equal to 0.22 and 0.16 respectively, because we are thinking that X is going to be much, much smaller than 0.16. And we can verify that assumption at the very end, and which that means is that essentially X needs to be lower or equal than the 5% of 0.16. Okay, so with this we can replace our equation for Kb. Instead of Kb, we're going to write down the numerical value. This is going to be equal to X times 0.22 divided by 0.16. Solving for X, this is 1.76 times 10 to the minus 5 multiplied by 0.16 divided by 0.22, which gives us a value for X of 1.28 times 10 to the minus 5. And what this X represents is the concentration of OH minus that we have in solution, as you can verify from the ice table. This is X at the end. Perfect. So with this, we can get the value for POH. The POH is minus the logarithm of that value, which gives us minus logarithm of OH minus is equal to 4.89. You can round it up as a 4.9 if you want to. And actually, that is what we are going to do since it tells us to express your answer to one decimal place. So this is 4.9. Thus, the value for pH is going to be 14 minus POH and is going to be equal to 9.1. This would be our final answer. So you can verify that this matches up the Henderson-Hasselbalch equation. Just remember that if you want to get the value for Ka, the product of Ka times Kb will be equal to Kw. And that will be all. Thank you very much.